Hi dear students, today we are going to discuss the chapter Surface Chemistry objective questions for EAP set. So the first question is identify the factors which favors the physical adsorption from the following. So physical adsorption. So first, what is adsorption? If you know the adsorption, first you have to learn what is adsorbate and what is adsorbent. Adsorbate and adsorbent means adsorbed substance is called adsorbate, adsorbing substance is called adsorbent. So from this concept, physical adsorption means adsorbate adsorbs on the adsorbent through van der Waals forces. So that is called physical adsorption. Through chemical forces, that is called chemical adsorption. So adsorbate on the adsorbent. What are the factors? So first one, high surface area. When surface area increases, adsorption also increases. So it is correct. First one is correct. Low temperature. If you apply the temperature after the adsorbate adsorption on the adsorbent, if you give the temperature, that adsorbate go to atmosphere. That means when temperature increases, adsorption, physical adsorption decreases. So at low temperature, high temperature, low adsorption, low temperature, high adsorption. So low temperature, physical adsorption more. High temperature, there is no physical adsorption. Low pressure. So if you apply the pressure, the gas is adsorbed on the adsorbent more and forms a strong bond. So that means low pressure is not applicable. At high pressures, physical adsorption more takes place. That means high surface area. Next, high pressure. When you apply the pressure, gases are come close to each other and forms more product, more yield. So high pressure. Next, high surface area, high pressure and temperature, very less temperature. At very low temperatures, the adsorption is more. At very low temperature, the adsorption is more. So it is the first question. Second one, in the given graph, the correct order of temperatures for curves 1, 2 and 3. For curves 1, 2, 3, which one has higher temperature? So we know that when temperature increases, adsorption decreases. When temperature increases, adsorption decreases. That means X by M means it is X adsorbate adsorbed on the given adsorbent, given mass of the adsorbent, and X grams, that means X grams of adsorbate adsorbed on the M grams of adsorbent. That process is called adsorption. It is directly proportional to P power 1 by M. So X by M is directly proportional to pressure. Adsorption is directly proportional to pressure. When pressure increases, adsorption also increases. After that, it is saturated. So when X by M increases, pressure increases. But when temperature increases, adsorption decreases. So when temperature increases, adsorption decreases. So here adsorption is high. So high adsorption, because X by M value is more. High adsorption. So adsorption high means it is low temperature. At here adsorption is low. So low adsorption. Here high adsorption X by M. Here X by M value is low. That means low adsorption means high temperature. So answer T4 is higher temperature. T4 greater than T3 greater than T2. So answer B. Very easy. When temperature increases, adsorption decreases. That concept. So high temperature, lower adsorption X by M. At low temperatures, high adsorption. So based on this, answer B. Okay, not this. See the next question. The sole prepared by Bredick's arc method is X. The sole is X and the charge of sole particles of it is Q. That sole particle charge is Q. So X and Q are respectively. That means colloidal soles are different types of soles. Positive soles, negative soles, neutral soles. Positive sole, negative soles, neutral soles. Bredick's arc method is used to preparation of metal soles like silver, gold, platinum, and that soles are negative charged soles. So answer is So Bredick's arc method. Bradig's arc method is used to preparation of colloidal salts, that is silver, gold, platinum salts. So metal salts, silver, gold, platinum are metal salts. Metal salt is 1, 2. So option A or B. That metal salts are negative salts, negative charged salts. So answer is A. So metal salt and negative charged salt. The next question is, which of the following does not show Tyndall effect? Tyndall effect means scattering of light. When light is passed through any solution, if the light is scattered in all directions, that is called Tyndall effect. So scattering of light is called Tyndall effect. That Tyndall effect is observed in colloidal solutions. Colloidal solutions. Solutions are three types: true solution, colloidal solution, suspension. True solutions are pure solutions. So that means true solutions are pure solutions, so pure salts. When the light is passed through the true solutions, straightly go through the solution. That means no scattering takes place. But colloidal solutions and suspensions. True solutions, colloidal solutions, suspensions. Colloidal solutions and suspensions particle size when compared to the true solutions is very large. So that's why that particles, when light passes through the solution, that particles are scattering the light. That is called Tyndall effect. So suspensions and colloidal solutions scattering of light is possible. That means clouds, milk and suspensions shows the Tyndall effect. Sugar solution does not show Tyndall effect. That means colloidal salt, suspensions shows Tyndall effect. So remaining sugar solution is a true solution. True solution does not show Tyndall effect. Next question for AS2S3 arsenic sulfide solution sol, that means colloidal sol, the most effective coagulating agent is. So we know that AS2S3 sol is negative charged sol. Remember, AS2S3 sol is negative charged sol. So here one trick and one important point: Hardy-Schule rule. Hardy-Schule rule means higher the negative charge of added sol, higher the coagulation, or higher the negative or positive charge. Higher the negative or positive charge, higher the coagulation. If the sol is negative sol, when you add positive charged sol, that positive charge has higher charge, higher the coagulation, lower charge, lower the coagulation. So here negative charge is AS2S3 negative charged sol. For this negative charged sol, which one has higher positive charged coagulating agent? That coagulating agent means when this solution is added to the sol, coagulation takes place, precipitation takes place. That is called, in which precipitation takes place more. In which precipitation takes place is more. Which one has higher positive charge? That one acts as most effective coagulating agent. So Ca plus 2, Na plus, Fe plus 3. So higher the charge, higher the coagulation. So answer FeCl3, because higher the charge, higher the coagulation takes place. Very easy. Higher the charge, higher the coagulation takes place. Lower the charge, lower the coagulation takes place. Next, sixth one, the minimum temperature required for a non-catalytic reaction between N2 and O2 is. So N2 gas reacts with O2 gas, it forms 2NO gas. It is a highly endothermic reaction. Endothermic means heat absorption takes place. It is a highly endothermic reaction, means high temperature required. Here in the reaction 1600 to, so remember 1600 to 2200 kelvins temperature required for this reaction. So which of the following is correct? 2000 kelvins. Remember N2 plus O2 gives rise to NO. 1600 to 2200 kelvins required. So it is highly endothermic reaction. Okay, note this. Okay, see the next question. The process in which collides when subjected to DC electric field move towards an electrode is. So it is the definition. When electric field applied to the colloidal solution, that colloidal particles moves to the electrode. That process is called electrophoresis. So answer electrophoresis. In the presence of electric field, colloidal particles moves towards electrode is called electrophoresis. So what is the Brownian movement? Brownian movement is zigzag motion. So zigzag movement of colloidal particles is called Brownian movement. So what is Tyndall effect? Scattering of light when light is passed through the colloidal particles or colloidal solution is called Tyndall effect. Peptidization means when already it is present in the precipitate, that means the precipitate form is converted into colloidal particles in the presence of suitable electrolyte. So when suitable electrolyte is added to the precipitation, that precipitate is break down into colloidal particle size. That colloidal particle sized formation is called peptidization. That means the process of precipitate into colloidal particles is called peptidization. So answer electrophoresis. Next question. The coagulation of 200 ml of positive colloid took place when 0.73 grams of HCl was added to it. For 200 ml of positive colloid, 0.73 grams of HCl was added. That means if you have 200 ml of positive colloid, 200 ml positive colloid, so addition of 0.73 grams of HCl without changing the volume much, the flocculation value of HCl for the colloid is flocculation value or coagulation value. Flocculation value or coagulation value, both are same. It is calculated for 1000 ml. So value or coagulation value is how many millimoles of electrolyte required for the coagulation of 1 liter of colloidal solution or 1000 ml of colloidal solution. That is called flocculation value. That means you calculate for 1 liter or 1000 ml, but here given 200 ml, here given grams, but you have to calculate in millimoles. Grams is converted to millimoles. First you have to convert grams into millimoles. 0.73 grams means number of moles of HCl equal to weight by gram molecular weight. 0.73 by HCl gram molecular weight 36.5. That means 73 into 10 power minus 2 by 36.5. So 2 into 10 power minus 2 moles. If it is converted into millimoles, 1 mole equal to 1000 millimoles. So 2 into 10 power minus 2 into 10 cube millimoles. So that means 2 into 10, 20 millimoles. For 200 ml colloidal solution, 20 millimoles is required. 200 ml, 20 millimoles required. For 1 liter, that means 1000 ml, how many millimoles required? So cross multiplication, 1000 into 20 by 200. So that equal to 1000 into 20 by 200. So 0, 0, 0, 0 cancel, 2, 2 cancel. So 100. So answer 100. So answer is D. So very easy. Wherever, whatever the given value, we calculate the number of millimoles required for 1000 ml of the colloidal solution, but he is given 200 ml of the colloidal solution. For 200 ml 20 millimoles, for 1000 ml how many millimoles? Easy, 220, 200,000 means into 5, so into 5, so 100. So 100 millimoles are required, so answer D. Okay, next question. The most effective coagulating agent among the options for Sb2S3 sol. So Sb2S3 sol, it is a negative sol. As2S3 or Sb2S3 sulfide sols are negative sols, negative colloidal sols. For negative colloidal sols, the coagulating agent is positive. For negative colloidal sol, coagulating agent is positive sol. So which one is positive here? Na2 plus, here Na plus, Al plus 3, Ca plus 2, NH4 plus. So most effective coagulating agent means higher the positive charge for the negative sol, higher the coagulation takes place. So that means higher the positive charge means Al2SO4 thrice. Al2SO4 thrice. Higher the positive charge, more effective, most effective coagulation takes place. Already one model explained before that. So most effective coagulating agent. So answer Al2SO4 thrice. Okay, not this. So the shape of isobar for physical adsorption and chemical adsorption respectively are. So physical adsorption means, so the rate of adsorption decreases with temperature. The rate of adsorption decreases with temperature is called physical adsorption. The rate of adsorption increases. The rate of adsorption increases and reaches the maximum, again decreases, that is the chemical adsorption. So that means for chemical adsorption activation energy is required, but physical adsorption activation energy is not required. So answer is C. First physical adsorption, second one chemical adsorption. So the rate of adsorption decreases with increased temperature. Decreases with increased temperature. So second one, rate of adsorption increases, first increases when increasing temperature, it reaches the maximum, again decreases. So that is called chemical adsorption. So answer C. Very easy and important one. Next question, very important. In an adsorption experiment, a graph between log x by m versus log p was found to be linear with a slope of 45 degrees. So first adsorption experiment means x by m is directly proportional to p power 1 by n. M is equal to k into p power, if you remove the proportional, x by m equal to k into p power 1 by n. If you apply logarithm, log x by m is equal to log k into p power 1 by n. Log xy. Log xy means log x plus log y. So log k plus log p power 1 by n. So log x by m is equal to log k plus log p power 1 by n means 1 by n log p. 1 by n log p. It is like y is equal to mx plus c. If it is y, it is m, it is x plus c. So if it is compared to y is equal to mx plus c graph, so here the slope is 1 by n. M means slope, 1 by n positive. So for the positive slope, the graph is here log x by m. Here on y axis log x by m, x axis log p. Log p. So the graph is, if the positive slope, the graph is like this. If the negative slope, the graph is downward direction. So it indicates intercept, y-intercept. Y-intercept is, what is the y-intercept here? Log k. Log k. So what is the slope? M is equal to slope 1 by n. 1 by n means tan theta. So by using this data, easily calculate the amount of adsorbed per gram of charcoal. So according to the given data, The intercept on the log x by m was found to be 0.3. So intercept is 0.3. That means log k is equal to 0.3. Log k is equal to, on which logarithm value? 0.303. So log 2 value 0.3010. That means k is equal to 2. So next, tan theta is equal to 1 by n. 1 by n is equal to tan theta. Tan theta means, what is the theta value here? Theta value is 45 degrees. So tan 45 degrees. Tan 45 degrees means 1. So that implies n is equal to 1. So k is equal to 2, n is equal to 1. By using this data, x by m is equal to k into p power 1 by n. K means 2. K into p power 1 by n. So that is equal to, k means 2, k is 2, p value is, the pressure is 1 atmospheric pressure. So that means 2 into 1 power 1 by n. 1 by 1. 1 power 1 by 1. So 2 into 1 power 1 by 1 means 2. So answer is 2. So very easy. Based on adsorption isotherm, x by m is directly proportional to p power 1 by n. Okay, not this. You see the next question in surface chemistry. 10 grams of a gas is adsorbed on 500 grams of the solid. So adsorbate is 10 grams of gas, adsorbent is 500 grams at 10 bar pressure. So pressure 10 bar. If the pressure is increased at 20 bar, 14 grams of gas is adsorbed by the same solid. So at the same temperature. So what is the slope of Freundlich adsorption isotherm? So what is Freundlich adsorption isotherm? X by m is equal to k into p power 1 by n. X by m is directly proportional to p power 1 by n. So x by m equal to k into p power 1 by n. In first case, 10 grams of gas. So 10 grams of gas adsorbed on the 500 grams of the solid. So 500 grams of the solid is equal to k into pressure. How much pressure? 10 bar pressure. So 10 bar, 10 grams, 500 grams. So 10 power 1 by n. Okay, next, it is 10 by 500 means 1 by 50. So that implies 1 by 50 is equal to k into 10 power 1 by n. In second case, if the pressure is increased at 20 bar, 14 grams of gas adsorbed by the same solid. So 14 grams adsorbed on the same solid means 500 grams, k into how much pressure? 20 bar pressure, 20 power 1 by n. So that implies 14 by 500 is equal to 14 by 500 is equal to k into 20 power 1 by n. So if it is 1, it is equation 2. So if you take 1 by 2, 1 by 2 implies 1 by 50 into 1 by 2, 500 by 14. So equal to k into, k cancel, 10 power 1 by n by 20 power 1 by n. So that implies 50 in 500 10 times. 10 by 14 means 5 by 7 equal to 10 power 1 by n by 10 by 20 whole power 1 by n. 10 by 20 whole power 1 by n means 1 by 2 whole power 1 by n. 5 by 7 means 0.7 is equal to 0.5 whole power 1 by n. So if you apply log 1, 0.7 is equal to log 0.5 whole power 1 by n. So that implies 1 by n is equal to log 0.7 by log 0.5. So you calculate this, answer is nearer to 0.46, that means 0.5. So answer D. So the mass of hemoglobin in milligrams required to protect from coagulation of 50 ml of a gold sol and adding 5 ml of 10% NaCl solution. So first, what is the gold number? What is the gold number? If you observe this, if you take 10 ml gold sol, 10 ml gold sol, if you add 1 ml of 10% NaCl solution, then the precipitation takes place. So for 10 ml gold sol, 1 ml 10% NaCl solution required, it converted to precipitate. To stop that precipitate, how many milligrams of protecting colloid required? That is the gold number. How many milligrams of protective colloid required to stop the coagulation when 1 ml 10% NaCl solution is added to 10 ml gold salt? So that is called, it is called gold number. So for gold number of hemoglobin for how many ml? For 10 ml gold salt, for 10 ml gold salt, so the hemoglobin gold number is 0.03 milligrams. So how much ml required? 50 ml. For 50 ml gold salt, how many milligrams of protecting colloid required? That implies cross multiplication. 50 into 0.03 by 10. 5 times 5 into 0.03, so that means 0.15 milligrams. So 0.15 milligrams required to stop the coagulation of 50 ml of a gold salt and adding 5 ml 10% NaCl solution. So very easy, gold number, very important. Okay, note this.